Hello everyone, welcome to David Griffiths Electrodynamics. This is going to be problem 5.3 from the book. As always, if you're new, welcome, and any returning subscribers, welcome back. If my videos help you out, feel free to support me by leaving comments, liking the video, subscribing to the channel, and checking out my membership options. All right, let's continue. So 5.3 states that in 1897, so this is a bit of a historical problem here, we have that J.J. Thomson discovered the electron by measuring the charge to mass ratio of cathode rays, or actually streams of electrons with charge Q and mass M, as follows. First, he passed the beam through a uniform crossed electric and magnetic field, E and B. So E and B were both perpendicular to each other, and then both of them were perpendicular to the beam. So the velocity direction was perpendicular to both E and B. And then he adjusted the electric field until he got zero deflection. What then was the speed of the particles in terms of E and B? Part B then says he then turned off the electric field and then measured the radius of curvature R of the beam as deflected by the magnetic field alone. So when he turned off that electric field, he knew he was going to get that sort of cyclotron motion. So he tried to measure what R was going to be in terms of, and then he said, and then the question says, in terms of E, B, and R, what is the charge to mass ratio? All right, let's look at this problem. So part A says that when he turned the electric field off, he got zero deflection. What then was the speed of the particles in terms of the electric and magnetic field magnitude? So if there's zero deflection, right? So he has this particle moving along, and then there's an electric magnetic field. He basically tuned the electric field to basically try to compensate for the obvious force that the particle is going to feel from the electric field, right? Or sorry, from the magnetic field, until the motion of the particle was straight and linear. So if there's zero deflection, then that means the net force, the electric and magnetic fields must be balancing each other out. The net force must be zero. So the total force, QE plus V cross B, so that's the electric force plus the magnetic force, this must be zero. And of course, the problem says that E and B are uniform, and V and E and B are perpendicular. So V and B are perpendicular to each other. So that means that, V cross B is just VB sine of theta. And if they're perpendicular, then that just gives us, sine of 90 degrees is 1. So V cross B ends up just being the magnitude of V times the magnitude of the magnetic field. And we're just going to deal with the magnitude of the force here. So the magnitude of the force is just QE plus QVB in this case. So then we can solve for the velocity here in terms of E and B. So the velocity is just, the Q's cancel off, and then you subtract E to the other side and divide by B, and you end up just getting V is equal to negative E over B. Then from equation for part B, where we need to solve for the charge to mass ratio, so we have an expression for the velocity of this particle in the electric magnetic field, but now he turns it off. He turns off the electric field, so now we're going to get the cyclotron motion, and we know that the motion of the particle is going to obey this equation, QVB equals mv squared over r, and we know what the velocity of the particle is in terms of E over B. So then what we end up getting is that QB is equal to mv over r. When we take this here, I just divided a factor of V out, and then I'm solving for the charge to mass ratio. That's going to be charge over mass. So Q over M is equal to V over BR, and then just plugging in our expression for the velocity of the particle, that's equal to negative E over B squared times R. And I believe that's it. Yeah, so this is a pretty short and simple problem. Not much to it. It's kind of a, I don't know, it's kind of a conceptual problem with a little bit of math, but nothing too crazy. So if this video helped you out or kind of got you unstuck, feel free to leave me a comment, like, and subscribe. And as always, guys, I'll see you guys on the next video.